How do we solve linear Diophantine equations in 3 or more variables? I would like to use this problem as a demonstration, and I would like you to attempt this problem in your homework. Variables with 4 or more equations with 4 or more variables can be done in the same way. And actually, in linear algebra, if we use matrix, this type of problem can be done easily. But now I would like to do this first problem as a demonstration. So first of all, I try to reduce this equation into 2 variable equation. That's why you see the left hand side, there are 2 variables, x and y. I try not to pick 2 and x and z, because the greatest common divisor of 2x and 4z, the 2 and 4 is 2, which is not as nice as the way that I chose. So I leave 2x plus 3y on the left side, move 4z to the other side, and you can see the reason right now. Because the greatest common divisor of 2 and 3 is 1, obviously divides any integer, so it must divide the right hand side 5 minus 4z, which means therefore solution exists, right? Solution exists. Actually, solutions exist. There are infinitely many solutions in this case exist. Now the second step is you basically repeat what you did previously when you solve linear Diophantine equations in 2 variables. The next step would be, so I'm gonna think, in this case, you think of z as arbitrary integer. Just think of it as an integer. So I'm gonna how about I make this, let z be arbitrary integer t. So in this case, the question becomes to solve 2x plus 3y equals another integer 5 minus 4t. Because 2 and 3, the greatest common divisor is 1, you can write this 1 as a linear combination of 2 and 3. So basically I can do 2 times negative 1 plus 3 times 1. If the question is more complicated, you can use Euclidean algorithm to write the greatest common divisor as a linear combination of the 2 coefficients. But in this particular problem, it's very nice. And then after that, I just need to multiply the both sides of the equation by 5 minus 4t. So here I have 5 minus 4t equals 2 times negative 1 times 5 minus 4t plus 3 times 1 times 5 minus 4t. Do you see that now? This is my solution for this equation. So therefore, I'm gonna erase that. Let me write my solution. So think of this as your x0, this is your y0, right? So therefore, my x is gonna be, actually we should simplify this. This is the same as negative 5 plus 4t. This is 5 minus 4t. So this is my x0, this is my y0. So therefore, my x is equal to my x0 plus y is 5 minus 4t. I should minus so that I can so that I find my general solution. So here this is my x, so I need to plus 3 times arbitrary integer, right? So I'm gonna write 3n. When this is minus, I need to write 2n. Of course, at the end you have 3 variables, So z is actually equal to t, right? So therefore this is t, this is t. Now this is your solution. This is solution. I'm going to show you, for instance, let's find couple sets of particular solution by doing the following. I need to add the page. Now, how do we find a particular set of solution? For instance, when t is 1, for instance, when t is 1, your x is going to be negative 5 plus 4 plus 3n, y is 5 minus 4 minus 2n, and z is 1. In this case, you can pick when n is 1, then x is negative 5 plus 4 plus 3, y is 5 minus 4 minus 2, z is 1. So in this case, you have 2, this is a negative 1, and z is 1. So 2, negative 1, 1 is one particular solution. So my point is you can vary the t value and n value, then you get the solution. For each pairs of different t and n, you get a different solution. So this is how I would solve this problem. And now for the next question, like part B, one thing I can quickly check is the greatest common divisor of 721 and 35 is 7. So 7 divides the left hand side, but 7 does not divide the right hand side. Therefore, in this case, no solution for the second equation. So that concludes my video, and again, I would like you to try the part C as one homework problem.